Well, innate immunity provides a really good first line of defense, but sometimes it's not enough to actually clear the pathogen from the body completely. And so that's when adaptive immunity comes into play. Adaptive immunity provides a much more specific response to pathogens, and this is the response that is mediated by antibodies and antigens. Antigens are just molecules or parts of molecules that can be recognized by something else. So we'll be talking a lot about antibodies and antigens in this next section, and we will keep in mind that they are specific for each other. Each antibody is specific towards one particular antigen. We'll get into that a little bit more later on. For adaptive immunity, the key players are lymphocytes. And lymphocytes are cells of the immune system, and they are housed in the thymus. So remember, our blood cells are made in the bone marrow, but then for lymphocytes, they travel to the thymus and finish development there. So end up being housed in the thymus primarily, but also the spleen and lymph nodes. So the thymus, where is that located? Thyroid was up in the neck. Thymus is down right behind the breastbone, kind of above the heart. That's where the thymus is located. And the thymus starts out large. In children, it's very large, and over time it shrinks as we age. It gets smaller and smaller, and that corresponds with a decline in our immune system's functioning. As we get into old age, it does start to decline. So in a normal healthy individual, there are two primary sets of lymphocytes that have major roles in adaptive immunity. Those two different types are T cells and B cells. So T lymphocytes, let's start with these. The T lymphocytes, their name, T, comes from the fact that they reside in the thymus. And then from there, once they are finished with their development, then they can go and travel to a few other sites in the body. They seed all the lymph nodes, which we have many of all throughout our bodies, and then also the spleen and the blood. They do circulate in the blood. What the T lymphocytes do primarily is attack cells that have some sort of a problem. So they could be cells that are infected with something. Maybe they have a viral infection. The T cells are specialized enough so that they can recognize that. They can recognize an infected cell from a healthy one, and they are very specific in their response. They only attack infected cells or cells that are displaying some other type of problem. A couple of other things that we'll be coming to later on is in the case of transplants, sometimes if you take an organ from one individual, transplant it into another individual, if the cell types are not closely matched enough, that can trigger the immune system to start attacking this transplanted tissue. So that has to do with the action of T lymphocytes, recognizing the fact that something appears to be foreign in the body. They also do a great job of keeping a lot of cancer cells in check and destroying them. We'll see a little bit more about that later on as well. Thing to keep in mind about T lymphocytes that sets them apart from B lymphocytes is that T lymphocytes have to be really close to their targets in order to do their job. They cannot act at a distance. Rather, they have to be pretty much right up next to the cell that they are going to attack and destroy. So that's a little bit of an intro for T lymphocytes. B lymphocytes, the B comes from bone marrow. This is where these cells come from. So B lymphocytes, primarily what they do is attack bacterial infections. They're not attacking our cells, but rather they are attacking specifically bacterial cells, and in some cases viral infections too. B lymphocytes are the cells that produce antibodies, and they keep a set of antibodies on their surface, like embedded in their own plasma membranes. So they're just kind of decorated with antibodies, but they also secrete antibodies, free antibodies that can circulate in the blood and also in the lymph. So B lymphocytes, in contrast with T lymphocytes, B lymphocytes can do their job from a distance because of that fact, the fact that they are secreting antibodies which can go into circulation. So a lot of times with these two different types of lymphocytes, we say that the T cells or T lymphocytes provide cell-mediated immunity. So in other words, the cell is the one that has to be right up there present next to the pathogen in order to provide some sort of immunity. But B lymphocytes, not so much. They provide humoral or antibody-mediated immunity. Humoral, that word is referring to the humors or the fluids of the body. And again, this is tying into the fact that antibodies circulate in the blood and the lymph. Lymphocytes are associated with specific organs. We've already mentioned what some of the major ones are. Primary lymphoid organs include the bone marrow and the thymus. So those are like the original homes of the two types of lymphocytes, B cells and T cells respectively. And then there are also secondary lymphoid organs. Secondary lymphoid organs include the lymph nodes that are spread all throughout the body. We've got a lot of them in our necks and throughout the body, but the ones in the neck are probably the easiest to recognize when they start to get enlarged if we're battling some sort of an infection. So lymph nodes, also the spleen, the tonsils, Peyer's patches, these are embedded in the mucous membranes of our intestines, and they have a very important job being located there. So a lot of the food that we ingest, it may contain some pathogens, and those Peyer's patches do a good job of capturing most of the pathogens and dealing with them before they make their way into circulation in the body. So the secondary lymphoid organs, their major jobs are to provide sort of like homes for the different lymphocytes, B cells and T cells. They also provide just a site for pathogens to be introduced to the lymphocytes and for the lymphocytes to learn how to deal with them and to replicate themselves into a high enough level so that we have enough immune cells to fend off something. I don't know if you can tell, it's very late at night. We're going to get through this though. Okay, so lymphocytes travel. They don't stay put. So they have a home. These secondary lymphoid organs are where they sort of hang out ordinarily, but from time to time they travel out and they go into circulation. So they go back and forth between being in circulation and being in these lymphoid organs. It's important that they travel out into the blood because the blood needs to be monitored, right? It needs to be monitored for pathogens. A couple of passes of the blood through the spleen and the liver, and it is pretty clean. In large part, or at least in part, that is due to the fact that the lymphocytes go out and monitor and check for pathogens being present there.